All right, welcome to Unit 6. This unit, our function that we're working with is what we call radical functions. Okay, a radical is just a fancy name for a root. Most of the time when we say radical, you're thinking of a square root sign. However, there are different kinds of roots we're going to be dealing with. Look at this one right here in example 2. It's a fourth root. Okay, there will be, we call them cube roots if they have a 3 there. Are there any cube roots? Nope. So, but fourth roots, square roots are the most common one. Please note that there's an invisible 2 right here. This is just a second root, like this is a fourth root. It could be a third root in your homework, but that's what a radical is. So when we solve equations that have to do with radical, there's 4 easy steps. So first step is to isolate or get the radical all by itself. So looking at example number 1, here's my radical. My radical is the square root of x. So I want that on one side of the equation, everything else on the other side. So I don't like this plus 5. So we're going to move that or make it go to 0 by subtracting 5 from both sides. Okay, so then my square root of x is now what we call isolated. It's all by itself over on the left side of our equation. 12 minus 5 is 7 right there. All right, now what we're going to do, the second step is to basically you've got to undo the square root. So the way that you do that is you raise each side of the equation to the power of the index. The index is just what root it was. So this again, remember, is a square root. So the opposite of a square root is going to be to square both sides of the equation. We're just going to square both sides. That way, again, these are what we call inverse operations. They just undo each other. So that square undoes the square root. So it turns it into just plain x. Just whatever is under that radical is the only thing that remains. So when I take the square root of x and then square it again, I'm back to that x. Okay, and then on the other side, I'm just going to square my 7. 7 squared is 49. So, we already moved on to step 3. That was solving the remaining equation. That actually solved it for us. Last thing you want to do is you do want to check the solution. Okay, these equations, just like our last unit, will have extraneous solutions. So I'm going to erase this so I can see better what my original problem was. And then we're going to check to make sure that when I plug in this 49 for my x, so if I have the square root of 49 and then I add 5, it should equal 12. What's the square root of 49? Well, it is 7. And indeed, 7 plus 5 is equal to 12. So that one checks. And we're done. All right, let's try this next one. So again, 4 easy steps. We've got to isolate the radical. Now, be careful on this one. Here's my radical. Okay, this negative is not part of the radical. This 3 is not part of the radical. So the 3 is pretty easy to take care of. We're going to just subtract 3 from both sides right there. That negative is still there. I still got the negative 4th root of m. That's equal to 0 subtract 3, which is negative 3. Remember, this is just their fancy way of saying either 0 subtract this one thing, but there's an invisible 1. I think the easiest way to do this to get rid of that negative 1 is just to divide both sides by negative 1. All right, so now our radical is isolated. We just have that 4th root of m is equal to negative 3 divided by 1, negative 1, which is positive 3. All right, so we've got a check mark on that first step. Now we've got to raise each side of the equation to the power of the index. So this time my index here is 4. That means to undo the 4th root, I'm going to raise both sides of my equation. Again, remember, if we raise the left side of the equation to the 4th power, we've got to do the same thing to our right side. These just undo each other. That just kind of takes care of that square root. So I'm left with just an m right there is equal to, and then in your calculator, 3 times 3 times 3 times 3, 3 to the 4th is just 81. Good. Again, we probably should have checked it before we circled it. Let's go ahead and plug this in to our equation. We have 3 minus the 4th root of 81. Is that equal to 0? To check this, I'm going to tell you a really easy way to plug this into your calculator. Most of your calculators do not have a 4th root button. Okay, what you do is you're going to turn this into a power. Your calculator can turn it into a power, or you could turn it into a power and your calculator can calculate it. So here's what I'm going to do is I'm going to kind of show you two forms here. We have what we call radical form, and then we have exponential form. So we can go ahead and write these lovely radicals in either form. So radical form looks like this. If you've got some base under here, I'm going to write this as a p. So that's our power. This is our root right there. We're just going to call it r for root. In exponent form, the b is our base. Our power always goes on top. Just remember thinking roots go into the ground. So roots are going to go into the ground. Powers go into the top. So it's going to be p over r. So you can go ahead, I'm going to make that a little bit bigger. So you could go ahead and rewrite it. So in this case, if you're plugging this into your calculator to check the fourth root of 81, you would just type in that base, which is 81. It doesn't have a power, so it's just an invisible 1 if there's no power there. So you could say this is to the power, which is 1 over the root, which is 4. Plug that into your calculator. Some of your calculators might need parentheses around it, but it should spit out a 3. Okay, so this, if you put it into your calculator, will be 3. So 3 subtract 3 is indeed 0, and that one checks as well. All right, let's do one more example in this video, then we'll put some more in the next video. Again, to isolate the radical, this time I've got 2 terms under my radical. I just have to move that 10. It's just added to my radical, so I'm going to subtract 10 from both sides. So now I have the square root of a plus 7 is equal to 11 minus 10, or 1. All right, second step, raise each side of the equation to the index. This is a square root, so we are going to square it, or raise it to the second power right there. I guess we could put parentheses there. These just undo each other, so I'm left with just what was under the radical to begin with. A plus 7 is equal to 1 squared, 1 times 1, which is still 1. And now we just solve. That's our next step. So to get a by itself, these before were already solved for us, but now we're just going to subtract our 7 from both sides, and a here is equal to -6. All right, before we circle that one, let's go ahead and check it. Plug it into this nice, lovely equation right here. So we're going to say 10 plus the square root of -6 plus 7 should equal 11. Let's check to make sure it does. Well, 10 plus, well, -6 plus 7 is 1. Square root of 1 is equal to 11. Square root of 1 is just 1. So we can go ahead and say, yes, indeed, 10 plus 1 is equal to 11. That checks. So go ahead and circle that answer. All right, that's the first 3 examples. We'll do the next 3 in video 2.